There are so many reasons I love studying astronomy. It's always inspired me. Like when I think about astronomy, I feel like it elevates me to my highest self. Big astronomy projects, whether it's a large telescope or a space-based observatory, these require large international collaborations. And not that I think astronomy will bring about world peace, but countries working together for a common goal, such a pure goal of knowledge about our universe, I think is something that we should encourage. I put this slide up the first day of class about constellations, and you've probably seen this using Stellarium. There are 88 defined constellations. The International Astronomical Union defined these 88 constellations and their boundaries. Constellations are like states. You're either in Virginia, or you're in Maryland, or you're in DC. You're not in between, and it's like that for the stars. Every star belongs to a constellation. There's no in-between space, and there are 88 of them. The ones in the northern hemisphere probably are more familiar to you, like Taurus and Leo and Ursa Major. Some of them in the southern hemisphere are a bit newer, and they're tools like microscopes and telescopes and ships. So to get started, we want to talk about points on the sky and use a model for the sky. I've put on everybody's table one of these. This is a celestial sphere. Right? So this is a conceptual model for describing the sky. It's conceptual because we know the Earth isn't really enclosed in a clear plastic sphere like this, and the stars aren't pasted on that sphere. But it's very useful for talking about the sky and where the stars and other deep sky objects are on the celestial sphere. To start with some terminology, the horizon is a word you might be familiar with. We consider it just sort of that imaginary plane where Earth meets sky. Right above your head is the zenith. Right? Everybody's got their own zenith. You guys good with angles? You remember some angles? So if the zenith is over my head and the horizon is here, how many degrees is that? 90 degrees, right? So your horizon is by definition 90 degrees off from your zenith, okay? And the horizon is this imaginary plane where the sky meets Earth. Okay? Here's a model of the celestial sphere. When we talk about this sphere, we talk about 2 points and 2 lines. The first point is where the Earth's north pole projects onto the sky. So imagine we all travel to the North Pole, and I have a laser pointer, and I just point it up right over my head at my zenith. That is called the North Celestial Pole. On your celestial spheres, it's where this little axis hits the top, right? That's the North Celestial Pole. You guys heard of the like pole star, North Star? Yeah, there's actually a star that happens to sit underneath this point. We're lucky. We'll talk more about that star Polaris in a little while, but it's just a coincidence that it's there. The other point is on the bottom of the celestial sphere. It's the South Celestial Pole. So it's the point where Earth's South Pole, if we go to the South Pole together, I take my laser pointer, I point it at the zenith, that's where the South Celestial Pole is. It's the projection of Earth's South Pole. Okay? Now for one of the lines, you notice where these 2 hemispheres meet? That's the projection of Earth's equator. And as you may have guessed already, that's called the celestial equator. So we've got 2 points in a line on our celestial sphere so far. So we've got the North Celestial Pole, that projection of Earth's pole, and the South Celestial Pole, and then we have the celestial equator as our coordinate system. Okay? This may start looking a little familiar to you, right? Everyone's seen a globe, yes, and how we find things on a globe. Astronomers aren't much different. The way you find things on a globe is pretty similar to the way you find things on the celestial sphere. So let's talk about what the sky looks like from different places on Earth. I know many of you have traveled. Many of you are from places very distant from Rockville. And you probably noticed the sky looks really different from different places. We're going to travel first to the North Pole, back again to the North Pole. We're going to see what the sky looks like. So again, if I am standing exactly on the North Pole and I point a laser at my zenith, I mark a point at the north celestial pole, okay? So we're up here. You guys know Earth rotates. How long does it take Earth to make one rotation? 24 hours, right? So if we're standing on the North Pole for 24 hours, now imagine you guys have that superpower in a stellarium where you can turn off the atmosphere and you can see the sun and the stars at the same time. So what do you think the sky is going to look like? You don't have to answer if you're feeling, uncertain about your answer, but I want you to think about it. All right, so yes and no. Yes and no, it doesn't change. Yes and no, right? So if we're standing, there's a star above us, and then there's like all these other stars, of course, around it, and Earth is rotating. And so it appears that the sky is moving, right? Because we're moving. It's us that's moving, right? We've got two motions we're talking about here. So we've got, if the chair is the sun, like over the course of a year, Earth does this, right? It makes one revolution. So let's stick with just this rotation, this 24-hour rotation. And the sun is out, but we can see the stars. And we're just watching the sky. So really, it's kind of like we're doing this, right? Slowly, over 24 hours. And so what it's going to look like to us is that the whole sky is rotating around this central point, right? No stars are rising, no stars are setting. They're all just kind of rotating in a circle above us over this 24-hour period. So we're going to walk now. We're going to get away from the North Pole because it's really cold, all that. We're going to start walking south. For just the sake of argument, let's pretend that this way's north and this way's south, okay? So we're going to turn towards the south, and we're going to start walking. What happens to that pole star, the North Celestial Pole? Will it stay over my head the whole time that I'm walking south? No, absolutely not, right? I'm walking down the globe. I'm starting up here, and I'm just going to like make my journey, right, down the globe. As I do so, that pole star slowly moves behind me, right? Yeah, and so I'll stop at Rockville. Maybe it'll be halfway up. All right. Now what happens if I keep walking south towards the equator? So, it's not warm enough in Rockville for me. I need to go even more south. So I keep walking south till I reach the equator. Where is the pole star? Where's the North Celestial Pole?
We are not able to see it.
Yeah, we probably won't be able to see it. It's going to be right on that northern horizon. It's going to be 0 degrees above the northern horizon. You're probably not going to be able to see it. And when you cross, the moment you take a footstep below this equator, it's gone too. You can't see it anymore, okay? All right. So if we're at the equator, what's our latitude? Does anybody know that? I don't know if they teach you guys this stuff anymore. Latitude at the equator. 0, yeah, 0 degrees latitude. What's latitude at the North Pole? 90, excellent, excellent. 90 degrees and 0. All right, so if Polaris was over my head when I was standing on the North Pole, how many degrees is it off the horizon? 90, okay. All right, now if I'm at the equator and Polaris is on the horizon, how many degrees is it off the horizon? 0. Do you notice a trend there? Wherever you are on the Earth, whatever your latitude is, that's how high Polaris is. So we start at 90 degrees. Say we walk to 70 degrees latitude, Polaris is going to be 70 degrees above the horizon. We walk to 60 degrees latitude, Polaris is going to be 60 degrees above the horizon. This is great, right? So now, if you're ever, I don't know, kidnapped and let out in the wilderness and you have to find your way, you can find your latitude. If you know where to look for the pole star, you can just like measure how far is it above the northern horizon, then you'd know your latitude. You have no idea where you are east-west on the globe, but that's a different story. We'll talk about that later. All right, here is the sky from Rockville, what the sky looks like from Rockville. Again, we start North Pole, walk to our latitude, which happens to be 39 degrees. We're 39 degrees above the equator. That means Polaris is 39 degrees above the northern horizon. Think about what happens when you face north. And what's going to happen if you turn off the atmosphere and you can see the stars and sun, you can see the stars all the time. Over 24 hours, what are they going to do? They're going to circle around Polaris, right? just like this. And over the course of 24 hours, it's one circle. Now, because we're mid-latitude, not all the stars are out all the time. Stars that are farther away from the North Celestial Pole will rise and set, right? Does that make sense? I will once again recommend my cure for insomnia. If this is terribly confusing, the thing to do before you fall asleep at night is to think about it. And think of the motions in your head. I guarantee it'll help you understand astronomy and it'll help you get to sleep too. This is a time-lapse photo. Somebody had their camera and they left the shutter open. And what you see are star trails. Okay? So this little guy is Polaris. He's not right at the center, but he's pretty close, right? So looking at this photo, you can start to see where it was taken, or at least have an idea of the latitude it was taken, right? Yeah, so it was definitely in the northern hemisphere, and probably somewhere midway between North Pole and equator, yes? Yeah. So the stars in this photo that never fall beyond the horizon, like the stars that just graze it but don't dip below the horizon, those stars are called circumpolar because they circle the pole. Go back to the North Pole with me for a minute. Look up. All right, the stars are all circling around Polaris, right? None of them are rising, none of them are setting. All the stars at the North Pole are circumpolar. Okay. Move back to the equator, right? Now, none of the stars are circumpolar. Polaris is right over there on your horizon. All the stars are rising, all the stars are setting, which is really cool because if you live at the equator, you get an opportunity to see everything, all the constellations. In the northern hemisphere and somewhere in the southern hemisphere as well, we don't get to see everything. There's another line on the celestial sphere that I want to talk about. So if you guys wouldn't mind taking a look at your celestial sphere, you can pass it around. It's not attached to the base, so just be mindful of that. Pops right off. If you look on that sphere, you'll see a dotted line. Do you guys see a dotted line with dates? Yeah? Is it lighting up for you guys to see a dot, like a dotted line? It's at an angle. Yeah. That line is called the ecliptic. What that is the apparent path of the sun. So again, I'm going to ask you to use your superpower of being able to turn off the atmosphere so we can see the sun and stars at the same time. Now, every day, you go outside at noon and you make a note of where the sun is relative to the stars. It's like, okay, it's in the constellation of Pisces. And what you do on your globe is you mark where the sun is every day at noon for a year. You go out, it's noon, you turn off the atmosphere, figure out where the sun is, and you make like a little dot. If you did that all year, you would end up with this dotted line. This is the ecliptic. It is the apparent path of the sun. Does anybody have any idea why it would be tilted relative to the celestial equator? Yes, exactly. Earth is tilted, right? You guys know by how much Earth is tilted? Oh, it's on here. Yeah, 23.5 degrees, right? So this dotted line is 23.5 degrees off of the celestial equator, right? Yeah. So just one more thing, if people can see it. So do you notice that there's 2 points where the celestial equator crosses the ecliptic? 2 crossing points? Yeah, and so yeah, you can kind of read off the dates. So I see one, it looks like the date is around March 20-something. And the other side, it looks like the date is around September 20-something. Do those dates seem at all special or familiar to you?
The equinox?
The equinoxes, yes. The first day of spring and the first day of autumn. By definition, the first day of spring and the first day of autumn is when the sun is at one of these 2 points, right? And then when the ecliptic is farthest away from the celestial equator, we have our solstices, the summer solstice and the winter solstice. Of course, depending on what hemisphere on Earth you're in. All right. You are going to see figures like this over and over through this module. So we're going to take a second to talk about it. This is an outsider's view of the solar system. So here's the sun, and here's Earth in its orbit around the sun. It takes a year for the Earth to go around the sun. So let's consider Earth June. On the night side of Earth, out here, you're going to be able to see these constellations, Scorpius and Ophiuchus, right? In August, you'll see different constellations high in the sky, say at midnight. This is great. This means we get to see the whole galaxy over the course of the year. Just as a reminder, okay, this is the sun, I'm the Earth, all right? And pretend this is rotating the whole time. So over the course of the year, we make one revolution. When you're on this side of the Earth, it's day, you see the sun. When you're on this side of the Earth, it's nighttime and you see the galaxy, all right? A few months later, again, day over here, but now you're seeing this part of the galaxy. You used to see that part, now you're seeing this part. Now you're seeing this part of the galaxy. Now you're seeing that part of the galaxy. Over the course of the year, our view of the galaxy changes. So we get a view of all of these different constellations. These constellations happen to lie on the ecliptic. Do they look familiar to anyone?
Zodiac signs?
Yes, these are the zodiac constellations, right? The Babylonians defined these about 3,000 years ago, right? And they may look familiar to you because of astrology, which, by the way, doesn't really work for a number of reasons we can go into later. Also, you may notice there's a constellation you may not have seen on the zodiac before, Ophiuchus. Ophiuchus has squeezed in there. The International Astronomical Union kind of drew the boundaries, and Ophiuchus is there. Let's go back to looking at June. So at nighttime in June, you can see Ophiuchus and Scorpius. In the daytime, when the sun is out, if you turned off the atmosphere, you would see the sun in the constellation of Taurus. A month later, in August, Sagittarius is high in the sky, and the sun is in Cancer. That's the definition of your zodiac sign, right? What is the sun in on the day you're born? A lot of people think their sign is what I can see at night on my birthday. No, it's what constellation the sun is in. The dates are wrong, mostly because of an effect known as precession, which we'll talk about probably next class. But the dates are shifted by about a month. And also we can add in Ophiuchus. Does anybody have a birthday like November 29 to December 18th or so? Yeah, when's your birthday?
October 26th.
October?
Oh, yeah, never mind.
Yeah, okay. You'll see your sign in a second. December back there? Did you say 14? Oh, we have the same birthday. Yeah, I'm also December 14. Yeah, so our so-called star sign is Ophiuchian. So we are proud Ophiuchians. He's a great constellation, definitely one of my favorites. All right, so here's the table where the sun is in on certain dates. So you can find your birthday. I mean, it doesn't mean anything. I'm not saying this means anything. It doesn't mean anything at all. But it's kind of fun to see where is the sun really on your birthday. Did anybody's star sign change? Yeah? Is your like mind blown now? It's like, oh, my whole life I thought I was a Gemini and I'm not. Yeah, so again, if you know anybody between these dates, Ophiuchians. Okay, so I just want to go back to this figure one more time and make it clear that it takes a month to go from here to here. That means the sun is in a particular constellation for about a month. It moves really slowly, right? The sun moves across the sky like a degree per day. So if the sun rises in Gemini, it'll be in Gemini at noon. It will set in Gemini, at 6 or whatever. And probably the next day, it's still going to be in Gemini. But over a month, it will slowly move. The motion of the sun through the constellations is slow.